Hey guys, today we are doing rates of change, which is basically applications of calculus, what we have been doing so far. Now there's two rates of change we should be familiar with. So the first one is the average rate of change. And this formula should look familiar because it is essentially the gradient formula, y2 minus y1 over x2 minus x1. And it measures a line between 2 points, which is pretty much the secant. The next one is the instantaneous rate of change, which is the same as dy dx, and it measures the tangent, the rate of change at 1 point. The only difference today is that instead of using x and y, we are using more actual variables. So we have q for quantity and t, which is time. So we are finding the rate of change of the quantity over time. Now the most commonly used when we are doing this is displacement, velocity, and acceleration. Now displacement measures distance from a fixed point, and it can be positive, negative, or zero. Now the difference between displacement and distance is, let's say for example, you go from there and you walk 50 meters and you walk back 30 meters. That means you covered a distance of 80 meters. However, in terms of displacement, is 20 meters because you are 20 meters away from where you started. So from the start is 20 meters. Now the velocity is the rate of change of the displacement. So it involves speed and involves direction. So with respect to x, which is displacement, over time. Acceleration is the same thing, but with velocity. So the change of velocity over time. So you have got velocity here with respect to time, or sometimes we use this little sign, which means it's the second derivative. So you derived the displacement, then the velocity. So you derived it twice. And both times you did it with respect to time. So we got displacement, velocity, which is the derivative of displacement, and acceleration, which is the derivative of velocity, or the second derivative of displacement. Now let's do this example. The mass in grams of a melting ice block is given by the formula m equals t minus 2t squared plus 100, where t is time in minutes. So we're going to find the average rate of change and the rate at which it will be melting in 5 minutes. So the average rate of change is going to be the y2 minus y1 over x2 minus x1, which in this case y would be m and x would be t. For b, we are going to do dy dx, find the derivative, but it will be dm, because m is the subject, over dt, because t is the variable. But before we do that, I want to do one thing, which is initial time, which actually isn't in the question. But when they ask for the initial time, all you got to remember is time starts at 0, so 0 minus 2, 0 squared plus 100 equals 100. Initially, it weighs 100 grams. Now, first one, between 1 and 3 minutes. So first we got to find the value of the mass, which we have to do m equals 1 minus 1 plus 100, which equals 99. And m3, because it's 3 minutes, 3 minus 2, 3 to 100, which equals 85. So we got the y values, or the m values, and then we have the time values. So we need to put it into the m1 minus m2 or m2 minus m1. It doesn't matter which way you go, as long as you put it in the same order. And that's going to be minus 7. So that means between 1 and 3 minutes, rate of change is minus 7 grams per minute. We do the exact same thing with between 2 and 5 minutes. Last part, rate at 5 minutes. So since this is an instantaneous rate, we have to derive. So dm over dt equals 1 minus 4t. Time is 5 minutes. That means 1 minus 4 times 5, which equals minus 19. That means rate of change at 5 minutes is minus 19 grams per minute.